In this video, I'll be working through the questions you see on the screen, and this question is from the winter edition of Cambridge International Exams from 2023 from paper 1-2. If you want any other questions from this paper, there should be a link to a playlist in the description below. I do these on a whiteboard, hopefully to mimic how you're used to watching your teacher teach these questions. And if you find any of this useful in any way, please like, subscribe, and even share it with some friend that's doing the exams or someone doing it next year. In question 10, they give us an equation of a curve, as you see on the board here, and they ask us to find the x-coordinates of the stationary points. And that's pretty much it. There is a part B for 1 mark, but this is the meat of the question here. Find the stationary points of this curve. Now, as soon as you hear stationary point, you should be thinking dy dx, the derivative. And you should be thinking the derivative is equal to 0 at these stationary points. So really, let's find the derivative of this. It's a hard enough derivative to do. We have to use the chain rule. I won't do it slowly, I'll do it quite quickly. The chain rule says we differentiate this bracket as if it was something else, like u is what the chain rule usually uses. So we get 5 over 3 multiplied by this bracket, 4x minus 3, and this power would change. It would come down 1. 5 over 3 minus 1 is 2 over 3. But that's cheating a little. This would have been fine if it had been x to the power 5 over 3, but it's not. So we cheated a little. We'll have to fix that cheat. And the chain rule says we can fix that by whatever we replaced there, whatever was in this bracket. And once we differentiate that and multiply it by it, it should fix it. And that's basically what the chain rule says. So the derivative of inside this bracket is 4. So we just multiply by 4. Or you can put it out front. And let's differentiate here. That's much simpler. It's just a number multiplied by x, just becomes the number. So that's the derivative, and that is equal to 0 at the stationary points. Because they asked us about stationary points, and the one thing we know is the derivative equals 0 at them. So we have an equation, only one unknown is x. We can solve this. Let's put this 4 into the 5 and we get 20. Let's move things over and move things around. We get 4x minus 3 to the power of 2 over 3 is equal to, this will become 20 over 3, and we'll multiply by the 3, and we'll divide by this 20. They'll all cancel each other and we'll be left with 1. Don't be careful, you're not left with 0 there. Remember, 3 divided by 3 is 1. 20 divided by 20 is 1. So we're left with 1 here. And we have to get rid of these powers. So let's get the cube of both sides. That'll get rid of the 3. 4x minus 3 squared is equal 1 to the power of 3 is still 1. 1 is a great number to deal with. Get rid of the square. Get the square root of both sides. 4x minus 3 is equal, careful, it's not just 1, it's plus or minus 1. Whenever there's an even number involved in these powers, you're probably going to end up with pluses and minuses. Okay, let's solve that. We will get 4x is either equal to 4 or 4x is equal to 2. That's x is equal to 1 or x is equal to a half. There are 2 answers, and they did only ask for the x coordinates. They don't want to know y in this case. We don't have to put y is the same as fx. We don't have to put that in. They only wanted these coordinates. But there's one other thing. They did want to determine their nature. Their stationary points. That means they wanted to find out, are they maximum or minimum? So again, when you hear maximum, minimum, when you see determine their nature, we should be thinking a second derivative. Let's do the second. I might run out of room. I think I'll have enough. The second derivative of something, second derivative of y in this case, is just differentiate the derivative. So 20 over 3 multiplied by 4x minus 3 to the power of this minus some number. So let's take this one first. 20 over 3 won't go anywhere. We'll end up multiplying by 2 to the power of 3. So that's 2 to the power of 3. Bracket we'll leave alone, 4x minus 3. We'll take 1 away from this guy. That'll become minus a third. And then we'll fix the cheat we're using in the chain rule. We'll multiply by the derivative of inside. That'll be a 4 here. Then the derivative of a number is 0. So that's it. We're finished here. Let's clean all this up. Let's see. 20 times 2 times 4 is 160. 3 times 3 is 9. 4x minus 3 to the power of minus 1 over 3. That's the second derivative. To determine the nature of these two, we need to put their numbers in. So let's see if I have room here. At x equals 1, let's put a line there, sorry. At x equals 1, the second derivative, I'll write it like that. We could have wrote it like that the whole time. The second derivative is equal, let's put 1 in here. That becomes 4 minus 3 is 1. 1 to the power of anything is 1. This is just equal to 160 over 9, which is bigger than 0, which means minimum. Yeah, I'll squeeze all this in here, which means minimum. So we have determined that this guy here is a minimum. That's enough marks. You've wrote enough there to say that. And then at x equals half, the second derivative is equal to what? So put a half in. 4 halves are 2. 2 minus 3 is minus 1. Minus 1 is not too hard to deal with powers. Minus 1 to the power of a third. So a minus 1, when you're getting to the power of a odd number, it just becomes, that's not a great way to say that. You know what, first of all, just put it in a calculator. Minus 1 to the power of minus 1 over 3. You will be told it is just minus 1. But you can think of it as this. It's the cube root of minus 1. They're asking you, what multiplies by itself 3 times to get minus 1? The answer is minus 1. And then this minus here just means you're going to divide by it. 1 divided by minus 1, again, is just minus 1. But again, put all this in the calculator. You should just get minus 1 for this part. Multiplied by here is minus 160 over 9. And that's less than 0, which means it's a maximum. And that's the answer to part A. For part B, I do want to draw a little picture. So let me rub out some of the board and I'll answer part B. So part B says, state the set of values for which the function f is increasing. Now, there's only 1 mark for this. So it should be no surprise to know that everything here is enough. The information we have already is enough to go, yes, that's the answer. Okay, but that's not that clear to a lot of students. So what I'm going to do is I'm going to attempt to quickly draw this function. So then we can quickly look at it and go, there, it's increasing there. So that's my attempt here, and it won't take more than 1 or 2 minutes. After I do a bad drawing, I'll throw up on the board the correct drawing of this function, because some of you will have good calculators that'll do it. If not, when you're studying, you can put it into a website to do. So how do I roughly draw this function once I have all this information here? I roughly draw it by asking myself the important points. I know where there's let's say a minimum at x equals 1. I know there's a maximum at x equals a half. And I know that's all the stationary points. So that's already a lot of information. The next thing I ask myself is, what happens at infinity? What happens when x goes really, really big? When x gets really big, this is going to be to the power of, 1.66. It's going to get bigger and bigger again. And then we're going to take away x to the power of 1, which isn't going to get nearly as big as this guy. So this number here is not going to matter. This guy is so much bigger than that. So at approaching infinity, fx will approach infinity. So I don't know, let me just draw an xy here. I don't know where it's actually going to hit though, so this won't be that accurate. When x gets really big, fx will get really big. Same with minus. When x gets really small, like minus 1 billion, this is going to end up being to the power of 5 over 3, which won't, neither of these are even, so we're not going to end up with well, the top one more importantly, is an even. So we're not going to end up with two minuses making a plus or anything like that. So this will just be a really small number. Minus a billion will become like minus 100 billion or what, I don't know. And then take away this, and again, this one won't matter compared to this guy. What I'm trying to say is, when you put in a really small number approaching minus infinity, it will approach minus infinity, somewhere down here. And I can say that just by looking at this very quickly. Then I've given some information about a half. Let's put a half here and one here. I know there is a minimum at 1. So a minimum somewhere here. Let's just pick a random point and say that's a minimum. So it has to look like that. And we know there is a maximum at half. Let's just say it's here. Has to look like that. And we know it goes down this way. So it has to look something like that. Like, it's just a rough guess. It probably won't look quite like this. In fact, let me throw up on the board what it looks like exactly with a computer generation. There. Hopefully, maybe it looks something like that, I'm not sure. But the general idea should be good. The general idea that it will always be increasing until this point. And then it'll always be increasing after that point. I can already tell that just by the minimum and the maximum and the numbers. But that's it visually. So basically, let's put in a half and 1. Basically, I can say when x is less than a half, it's increasing. So they're asking, when's it increasing? Well, when x is less than a half, remember, we read left to right. It's always going up. Then it's not increasing between a half and 1. And then again, when x is bigger than 1, it's increasing again. This is all they wanted for part B. If you just wrote this, you get full marks. You don't have to draw a picture. You don't have to say anything I said. I'm just trying to explain it as best I can, which probably isn't the best. If you have any questions about that or anything else, put them in the comments. I'll do my best to answer. Thanks for watching. Have a great day.